Okay, so the part of the lesson I didn't get to yesterday was factoring. So let's say I have x squared minus 28. Because it's two terms, what is my option here for this to be a what? A dot. Is 28 a perfect square? No, but now that we've introduced radicals in our lives, we can still factor this using radicals. So because it's a dot, we know it's going to be x plus something, x minus something, and then it's going to be what times itself gives me 28. So what I'm going to do is I'm going to go ahead and I'm going to take the square root of 28 and I'm going to factor it. So when we break down 28, can't we do 4 and 7? And then 4 is 2 and 2. So this gives us 2 root 7. So doesn't that mean 2 root 7 times 2 root 7 gives us 28? So it's going to be x plus 2 root 7, x minus 2 root 7. All right, I'm going to step it up a little bit now. So doing a dots is pretty easy because really you're just taking the square root of that constant term and then it becomes a plus and minus and that's all it is. But when we're dealing with a trinomial, it's a little bit different. So for a trinomial, let's say we have x squared minus 2 root 5x, that x is not under the radical, plus 5. All right, so when we come to factor this, we're going to factor the way we normally factor. When it's just a trinomial with a leading coefficient of 1, don't we generally say, well, I need 2 factors of 5, so 2 numbers that multiply to 5, but now that also add to a negative 2 root 5? So factors of the last term that add to the middle term. That's what we're looking for. The only way to add to a radical is if both numbers have that radical in it. Do you agree? So when we come to figure this out, I know right off the bat, I need to use root 5 and root 5. And now if I'm multiplying to a positive, but I need to add to a negative, both of these root 5s have to be what? Negative. Well, this one's a little bit simpler because if I had root 5 times root 5, what is that? Or negative root 5 times negative root 5. Isn't that positive 5? And then check it over here, negative root 5 plus a negative root 5. What's negative root 5 plus a negative root 5? Negative 2 root 5. So I didn't have to play around with the coefficients much, right? Because me just breaking down into the 2 radicals sort of fixed that for me. So now when we come to factor, we're using the 2 numbers that we guessed with the radical here, the factors. So this is going to be x minus root 5 and then another x minus root 5. Or I can put it as the quantity of x minus root 5 squared. Let's do one that doesn't work out that easily, where we have to think a little bit more. Let's say we have x squared plus 8 root 2x, that x is not underneath the radical, plus 30. Again, I need factors of 30 that add to a positive 8 root 2. So the only way to add to a radical is if both factors have that same radical in it. Do we agree? So now I know when I break this down, I'm going to need to have a root 2 and another root 2, and we're going to need to play around with the coefficients a bit. In order to multiply to a positive and add to a positive, do both factors have to be positive? Yes. So we know both factors are positive, and now this is where the playing comes around. We're multiplying these factors. So right off the bat, when I do root 2 times root 2, what is that? 2. So here I already have 2. Now I need to figure out, what do I multiply 2 by to get 30? 15. So I know 2 times some number has to give me 30. So the remaining number is 15. That means my coefficients for the radical have to multiply to 15. But they not only have to multiply to 15, they also have to add to 8. Does anybody need me to repeat that? No? Okay, so tell me, what are 2 factors of 15 that multiply to 15 but add to 8? Aditya. 3 and 5. Right? So we're going to check this. 3 root 2 times 5 root 2. 3 times 5 is 15. Root 2 times root 2 is 2. 15 times 2 is 30. That works. 3 root 2 plus 5 root 2, is that 8 root 2? That also works. So we come to factor. We're going to write down our factors. X plus 3 root 2. X plus 5 root 2. All right. Let's keep going. Let's have you try one on your own, and then we'll move on to today's lesson. So I want you to factor x squared minus root 6x, that x is not under the radical, minus 72. You guys do understand, if I wrote this x squared minus x root 6 minus 72, that's the same thing, right? Yes? Do we recognize this and this are the same thing? Okay, good. Because sometimes you'll see it like this, sometimes you'll see it like this.
That's doing 72 times 6.
Can we go over this? Anybody want another minute? Okay, so we're going to break this down. The only way to multiply to a negative 72 but still add to a negative root 6, both factors have to have a root 6 in it. Do we agree? Root 6 times root 6 is 6. So now we're going to say 6 times what number will give me, well, negative 72. Let's just keep it positive for now. We'll figure out the negatives later. 6 times what gives me 72? 12. What does that mean? That means my coefficients have to multiply to 12. Not only do they have to multiply to 12, they have to add to a negative 1. So do we agree, in order to multiply to a negative and add to a negative, one has to be positive, one has to be negative? So we need a positive and a negative. So what coefficients multiply to 12 but add to a negative 1, or multiply to a negative 12 and add to a negative 1? David?
Negative 4 and positive.
You got it. Positive 3 and a negative 4. So this gives us x plus 3 root 6, x minus 4 root 6. How many people got that correct? Good. All right, so that was the end of yesterday's lesson. Let's move on to today's lesson. I do have a do now for you. We're probably not going to finish this lesson today. We'll see how far we get, because the do now itself will take a while. So we are Unit 6, Day 3, and this is just titled Other Radicals. I have 2 do now problems for you. Here's the first one.
Why is there so much room?
You don't really need that much room for that. I don't know why I did that.
We're supposed to simplify.
Yep, directions are to simplify, sorry. Yes. I had to give you a doozy to try on your own. Question for the first one. Can you make this? Can you do it like that? Good. Why? Because it's a binomial. You cannot split a radical through a binomial. You cannot. So that does not work. How many people did that? Be honest. Somebody did it. At least 5 people did it. I'm not even going to lie. I know at least 5 people did it.
Wait, this is crazy.
That's why I started with I did all of it. I know that. So I'm right so far?
Wow. That was so close, but also so far. You got 2 terms right.
Negative 62 plus 34 is 16 minus 32 40 plus 70 over 360. That's not good.
Did you get to the first one? Where'd you get that from?
All right, are we ready? No? Are we ready? You guess? Okay. Let's just go over answers first. Who has, I want to see different answers we got. For number 1, who thinks they got an answer? Simon.
Square root of a squared plus b squared over 8.
Did anybody get anything different? David.
I got like 1 over a plus 1 over b.
If you got 1 over a plus 1 over b, that means you did this. Okay, so then What do you mean? So you did 1 over a squared plus 1 over b squared and then the square root? Okay, but then you still ended up splitting a radical through a plus sign, right? So then you got 1 over a plus 1 over b. Are we allowed to split a radical through a plus sign? Are we ever allowed to do that? No. So let's take this one off the table. Did anybody get anything different? No? How many people got this then? So that means y'all got something different, but nobody wants to share? All right, should we do it? I'm not going to tell you if this is right or wrong. Let's do it. All right, so we are not allowed to split a radical. We are not allowed to split a radical. So I am going to start out how David started. I'm going to write this as 1 over a squared plus 1 over b squared. That was the perfect way to start this. But we can't oversimplify this. Remember, we cannot break up a radical through a plus sign. If that was a multiplication sign between them, would we be able to? Absolutely. But because it's a plus sign, we can't. So now we need to just simplify within the radical. What do I mean when I say simplify within the radical? It means I need to add these. How do I add these? By creating a what? How do you add fractions? By creating a common denominator. We need to create a common denominator. What is my common denominator? A squared, b squared. Oops. So in the first fraction, I multiply by b squared. In the second fraction, I multiply by a squared, not a today. And now we combine our like terms. So now I have an a squared plus b squared as my numerator. And in my denominator, I have the root of, I have a squared b squared. Because this is now one fraction, can I go from one illegal thing to another? Can I make the numerator a radical and the denominator a radical?
Yes.
Absolutely. That's what I'm going to do. So now this is going to become the root of a squared plus b squared over the root of a squared b squared. This is nice because a squared b squared is a perfect square. So now we have the root of a squared plus b squared. Is it okay to have a radical in the numerator? Absolutely. And then ab in the denominator. Was Simon correct? Yes. Good job. All right, let's look at the second one. So I don't even know if my answer is right, to be honest. This was root 2 over root 30 minus root 2 plus 3. It's so easy to make a little arithmetic error here. All right, who thinks they have an answer for me? Let's get all of our answers. David. Don't be scared. I'd rather the wrong answer than no answer at all.
30 root 15 minus 72 root 2 minus 12 root 30 plus 72 over 339.
Say it again.
30 root 15 minus 72 root 2 minus 12 root 30 plus 70 plus 72 over 339. I definitely did something wrong. I definitely.
Kaylee.
Negative 38 root 2 plus 74 minus 69 root 2 minus 12 root 30 over 289. Over 20.
Any other answers?
289.
Oh, 289. Any other answers, Chris?
Negative 63 root 2 plus 34 root 13 minus 12 root 30 plus 70 over 217.
217. Any other answers?
Oh wait, I'm sorry.
Okay.
Negative 38 root 2 is a root 15.
This one?
Yeah.
All right. Any other answers for me? All right, let's see. Did anybody else get the same answer as the first one? The 30 root 15 minus 72 root 2 minus 12 root 30 plus 72 all over 339. All right, did anybody get the same answer as the second one? Negative 38 root 15 plus 74 minus 69 root 2 minus 12 root 30 all over 289. Did anybody get the same as the third one? All right, I'm not going to tell you who's correct or if anyone's correct. Let's do it. Okay, so we are going to sort of treat this as if it were a binomial. So we're going to multiply the denominator by the conjugate. So what I'm going to do is I'm going to sort of make the root 30 minus root 2 sort of one term on its own. That's sort of like a, and then I have plus 3. So now when I multiply by the conjugate, I'm going to do root 30 minus root 2 minus 3. Oop, let's put brackets here. All right, so now we need to triple distribute this. All right, root 30 times root 30 is 30. Root 30 times a negative root 2 is a negative root 60. Root 30 times a negative 3 is a negative 3 root 30. Now let's go on the root 2. Root 2, negative root 2 times root 30 is a negative root 60. Negative root 2 times a negative root 2 is a positive 2. Negative root 2 times a negative 3 is a positive 3 root 2. Not done. Now we're going to triple distribute the 3. 3 times root 30 is a 3 root 30. 3 times negative root 2 is a negative 3 root 2. And 3 times a negative 3 is a negative 9. All right, let's combine our like terms. So here we're going to have 30 plus 2 minus 9. So 30 minus 9 is 21, plus 2 is a 23. Do we agree that the negative 3 root 30 and the positive 3 root 30 will cancel? And then I have a positive 3 root 2 and a negative 3 root 2 will cancel. So then I'm left with negative root 60 plus a negative root 60, which is a negative 2 root 60. But what can I do with this root 60? You got it. We can simplify this. So 2 root 60, if you break this down, what can you do? You can break this into 4 and 15. You got it. And then 4 becomes 2 and 2. There's your pair. So this is 23 minus 4 root 15. That is our new denominator. I know, it's a lot. So now our denominator is 23 minus 4 root 15. Our numerator, we're just distributing that root 2. So when we distribute that root 2, we're going to get root 60. Somebody tell me, I can't see. Root 60 minus 2. Root 60 minus 2 minus 3 root 2. Okay, can we simplify the root 60 again? Yeah, what does that end up becoming? 2 root 15 minus 2 minus 3 root 2 all over 23 minus 4 root 15. Once again, what am I going to do? Multiply by the conjugate. So this is going to be 23 plus 4 root 15. 23 plus 4 root 15. All right, 23 times 23, 529. 4 root 15 times 4 root 15 is going to be 16 times 15, which is going to be a negative 240. Oh boy, this numerator. I don't know why I gave you this problem. All right, let's do it. 2 root 15 minus 2 minus 3 root 2 times 23 plus 4 root 15. All right, 2 root 15 times 23 is going to be 46 root 15. 2 root 15 times 4 root 15 is going to be 8 times 15. All right, and moving on to the negative 2. Negative 2 times 23 is a negative 46. Negative 2 times 4 root 15 is a negative 8 root 15. Last one, the negative 3 root 2. Negative 3 root 2 times 23 is a negative, is that 69 root 2? Negative 3 root 2 times a 4 root 15 is a negative 12 root 30. You guys got to catch my algebra in case I'm messing anything up. All right, so now let's simplify this. Oh boy. 8 times 15. Did anybody multiply that? 120? 120 plus 46, oops. 120 plus 46 root 15 minus 46 minus 8 root 15 minus 69 root 2 minus 12 root 30. Okay, let's combine our like terms. So then we have 120 minus 46. 120 minus 46 is going to be 74. All right. Now I have a 46 root 15 minus an 8 root 15, which is going to give us positive 38 root 15. Kaylee, you were so close. And then we're going to have a negative 69 root 2 minus 12 root 30. Let me write it smaller. All over, what was that bottom number, 289? Oh, so close. There we go. Did anybody get this? Oh, now you're offering your answer, Aditya. Uh-huh.
I wrote 24 instead of 23. You didn't even get it.
Okay, so that was our very long do now. Let's get into today's lesson. What? Aren't all the doozies on the tests? Yeah. All right. All the doozies are on the test. Guys, you're in the highest level Algebra 2 that we offer in the school. Will the hardest problems be on the test? Yes. Not by my choice. All right, so let's just recap real quick. When we have a radical, the number underneath the radical is called the radicand. The number by the check mark. Up until this point, there's been no number written here. But the very first day we spoke about it, right? If there's no number there, it's implied that it's a 2. That number can change. That number by that little check mark is called the index. And then the actual radical can be called a radical or a root. If it's a 2, square root. If it's a 3, it's like the cubed root. So some kinds of root. All right, so we are going to change the index from 2 to other things. So my directions are to simplify. Let's start off simple. Let's say I gave you the cubed root of 8. All right, this time I don't want twins. What do we want? Triplets. We want triplets. So we're looking for groups of 3. So I can break that 8 down into 4 and 2. I can break that 4 down into 2 and 2. There's our triplet. So what times itself 3 times gives us 8? 2. Hey, if you can do it in your head, do I want you to do it in your head? Absolutely. If you can simplify in your head, I want you to simplify in your head. Save yourself time. All right, let's work at variables. If I have the cubed root of x to the 12th, now when we were taking a square root of a variable, didn't we take the exponent and divide it by 2? Well, now I'm changing the index. So it's going to be the same shortcut, but I'm not going to divide by 2. I'm going to divide by whatever the index is. So here I have x to the 12th. I'm going to take that 12 divided by 3. So what's this going to be? X to the 4th. That means there's going to be I'm going to show you the long way just to show you. There's going to be 4 groups of x. So 1, 2, 3, 4, 5, 6, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Here's a group of 3. Here's another group of 3. Here's a third group of 3. Here's the 4th group of 3. So that's how we get the x to the 4th. All right, let's combine. So now I'm not looking for the cubed root. Now I'm looking for the 4th root of 48y to the 6th. I'm looking for the 4th root of 48y to the 6th. So now I'm looking for groups of 4. So let's break down 48. 48 gets broken down into 12 and 4. Is that good? 16 and 3. Whatever you want. 12 gets broken down into 4 and 3. The 4 will get broken down into 2 and 2, 4 again, 2 and 2. So now I need a group of 4. Where's my group of 4? The 2's. So what does that mean? 1, 2 is going on the outside. Is there going to be numbers left over, or will there be numbers left over? Absolutely. So I'm going to make the radical. What is necessary for me to put in this on the outside of this radical by the check mark? The index of 4, because now it's the 4th root. And then we're going to have a 3 left over. Let's go to y to the 6. We're going to use our shortcut. 4 goes into 6 how many times? 1 time. That means 1 y is getting taken out. How many y's are left over? 2. So y to the 2nd on the inside. All right, you all try this one on your own. The 5th root of 64, x to the 2nd, z to the 11th. Okay, tell me, What did you get for the fifth root of 64x to the second z to the 11th? Dylan.
I got 2z squared root 2x squared z.
I got the same thing. Anybody want to see me do this? No, we're good? We all got this? Yes? Oh, yes, the fifth root. Thank you. We do need to put the 5 there. We need to have the 5 by the check mark. All right, now, if the index is odd, we can have a negative underneath. So if I have the cubed root of negative 125, because can't there be a number times itself 3 times that will end up being negative? Yeah. So what times itself 3 times will give us a negative 125? A negative 5. All right, what happens if it's not a perfect cube? So let's say I have the cubed root of negative 40. So when we break down 40, again, we want triplets. So we're going to have 4 and 10. And you'll see what I'm going to do at the end. I'm just looking at the 40. This is 2, 2, and then the 10 is 2 and 5. Whatever threesome I grab, whatever triplet I get that I'm going to pull out, that's what I'm going to be negative. So that's going to become a negative 2, because negative 2 times negative 2 times negative 2. So I'm going to pull out that negative 2, and then you leave the positive number on the inside. So that 5 that's left over goes on the inside. So this is negative 2 times the cubed root of 5.
Could I pull out like the positive 2 and leave the negative?
No, we don't leave the negative inside. Negative will always come out. Anything else I wanted to show you? Okay, let's look at this next one. One over the cubed root of x squared. Okay, so when it was a square root in the denominator, weren't we just multiplying it by itself? Right, but if you were to just multiply this by itself again, you would have the cubed root of x squared times the cubed root of x squared. Wouldn't you get the cubed root of x to the 4th? And wouldn't that just be x cubed root of x? Still a radical, right? So now what we're going to do in order to rationalize is we are going to look at the index. My index is 3, right? That means I need a group of 3. I already have how many x's under here? 2. How many more would I need to make a group of 3? 1 more. So what I'm going to do is I'm not going to multiply it by itself. I'm going to multiply by whatever it takes to make a group. So that means I'm going to multiply by the cubed root of x times the cubed root of x. So in my numerator, I just have the cubed root of x. In my denominator, wouldn't this be the cubed root of x cubed? Which is what? X. So we have the cubed root of x over x. Oh, there we go. All right, I forgot the periods were shorter. We're done for today, I guess. No